Hi, today's topic is area of a scaled figure based on the original figure. So in other words, what happens when we scale a figure? What happens to the area of that figure? So we're going to do a little experiment, and hopefully we are in school today so that we can do that in person. However, if you are learning from home, I'll kind of walk you through this, and I will also provide you with a link to some virtual manipulatives that you can use. So, thought I would just make this big question and we'll come back to that. Here we have scaling a pattern block. So this is our experiment, and we have three shapes we're going to work with. We have a rhombus, a triangle, and a trapezoid. So I actually have these in front of me, and I'll be using these to show you my outcome. I encourage you to stop along the way to work these out either with your virtual manipulatives or if you have some manipulatives at home, if you're working at home. So, moving on. Question number 1. How many blue rhombus blocks does it take to build a scaled copy of figure A? So here's figure A. And I have created this table to kind of help us stay organized and find any patterns. So if I'm looking at the scale factor of 1, that would be the original. So we're going to say this rhombus has an area of 1 unit. This is our unit. So what if I use a scale factor of 2? What if I make this twice as large? Then we'll find the area of that. So if I can compare my original to a figure that's twice as large. Now if it's twice as large, that means both the length and the height have doubled. So my new area, when it's using a scale factor of 2, it's going to be 1, 2, 3, 4 figures. Okay, 4 units. Okay, now what if I triple it? Then I would need to go from the original 3 times as tall and 3 times as wide. And if we count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I wonder if you can guess what this will be. If I took my original figure and made a new figure that was 4 times, scaled up 4 times, then what would the area of the new figure be? So hopefully you came up with 16 blocks for a figure that was scaled using a factor of 4. Now I didn't build that, I just looked that up. So our end goal is going to be to try to determine what if the scale factor was x. In other words, how am I going from the original figure to the scaled copies regarding the area, okay? So let's look at the triangle and see if we can find the pattern. So here I have a bag of triangles. Here's one triangle. So the scale factor there is 1. Now, what if I doubled it? What would happen then? So here I've made a triangle that is twice as large as the original. This was the original. This one is twice as wide and twice as tall. So the area, if I'm measuring by this unit, okay, so I'm saying each of this shape is 1 unit, then the area of the figure that is created using a scale factor of 2 is 1, 2, 3, 4. I wonder if the third iteration will be 9, like in the other shape. So instead of building these, I actually, I would like you to pause and build these for yourself, but I have a picture of what they're going to look like. That way, it'll be a little neater. So if I did it, notice how this is 3 times as wide and 3 times as tall, okay? And that's 9 blocks. And then this one, look here, 1, 2, 3, 4, 1, 2, 3, 4. So compared to the original one, this last one here is 4 times as wide and 4 times as tall. And again, it's this would be a scale factor of 2. This is a scale factor of 3. And this is a scale factor of 4. So the area didn't just double, and the area here didn't just triple. And the area here wasn't times 4. So let's look at our chart. These did turn out to be the same. So if I took my original and I just doubled it, that would be 2. But it wasn't 2. I wonder if it's because I did the length and the width. I doubled each of those. I wonder if that's why I came up with 4. And then here I tripled the length and the width. Here I quadrupled the length and the width. All right, we have one more shape to look at, and that shape is a trapezoid. Let's remove these little blocks. Okay, so here's the original one. This is our unit of measurement. We're saying the area there is 1. So what if I doubled it? What if it were twice as tall and twice as wide? I think I'm doing this right. Let's probably turn it around so it looks more like the original. Okay, so let me show you the original. Okay, and here it is twice as tall, twice as wide. So the new area, when I've doubled the length and the width, 1, 2, 3, 4. Okay, and I will show you a picture of the other iterations. Now building these takes a little more work, so I don't blame you at all if you kind of snuck a peek here. You will see that just like the other times, when I have doubled my original, that I now have an area of 4, which is not twice as much, but 4 times as much. Okay, and this one, when I tripled it, it's not 3 times as much as the original. Remember, the original was one block, so it's 9 times as much. This one isn't 4 times as much, but it's 16 times as much. And the reason is because we are not just doubling the length, we are doubling the length and the width of these figures. So the area is not changing by just a multiple of 2. It's changing by 2 by 2 and 3 by 3 and 4 by 4. So I'm not sure if you remember about exponents, but another way to write 2 is, or 2 times 2 is 2 squared. 3 times 3 would be 3 squared. 4 times 4 is 4 squared. So if the original figure is scaled by a factor of x, the new area would be x times x, which would be x squared. Okay, that's what I would multiply the original by. So to get the new area, we would take the original area times the scale factor squared. Okay. Whoops. All right. So, in conclusion, the area of a scaled figure is the area of the original times the scale factor squared. Now, I think for our purposes in 7th grade, this is a bit more complex than you have to understand. But if you do understand this, then it will help you to make it easier. But if that seems too much, go back here and think about it like, okay, I take the original area and multiply it by the scale factor, once for the width and once for the length. So I would do the original area times the scale factor times the scale factor. And that concludes this lesson.